Next up in part 4, after we've talked about rational functions and polynomials and lines and quadratics, we're going to talk about rationalizing a denominator. So by rationalizing a denominator, that implies that we're dealing with irrational or imaginary numbers. And the way that we do this is take what's in the denominator, and we're going to multiply the numerator and the denominator by the conjugate of the denominator. Now you might be saying, Mr. Swenson, okay, I understand numerator, I understand denominator, I kind of understand rationalizing, but this word conjugate, this might be in the second time that you said it. The first time we said it was the difference of squares factors to conjugate pairs. Conjugates are the same linear binomial with alternating signs. So for instance, if we are given an irrational denominator, this problem says the square root of 3 plus the square root of 2 is in the denominator. In order to rationalize, we multiply the denominator and the numerator, which in essence is multiplying by 1, by negative root 3 minus negative root 2. And whatever we do to the bottom, we're going to do to the top. And by doing this, the numerator becomes the irrational part, which is fine. We just distribute 2 root 2. And the bottom, because the difference of squares are conjugate pairs, all we have to do is multiply the first and multiply the last, and we're left with 3 minus 2, which leaves us with the answer of 2 root 3 minus 2 root 2. Now, please don't make the freshman mistake in trying to simplify what's underneath the square root signs. Those are two separate terms. We keep them separated. Likewise, if we're dealing with imaginary numbers, also something that is not rational, we do the same thing. So we take the conjugate, 4 plus 7i, 4 plus 7i, and we distribute on both the numerator and the denominator. So we have 8 plus 14i on top, and on the bottom we have 4 times 4 is 16. Negative 7 times 7 is negative 49i squared. And if we remember that I is the square root of negative 1, and I squared therefore is negative 1, what we can do is change the I squared and change the minus sign, and now we are left with 8 plus 14i all over 65. And just so we can be super specific, we will write our real part as 8 over 65, and then our imaginary part, 14 over 65i. You'd be surprised at how that's something like that simple technique of rationalizing a denominator shows up in multiple situations, especially when we're dealing with limits that we can't simplify out quite so easily. Next up, absolute value. Another fun concept that people don't really like to deal with because they don't quite understand it. And if I put this into a context, like obviously you remember that an absolute value is a positive number generator. But that doesn't do us a whole lot of good if we don't know what to actually do, especially with a variable. Another way to think about absolute value, if you go to physics, they use this same symbol to talk about the magnitude. And the magnitude is really talking about the distance from the origin. So oftentimes we deal with absolute values in terms of a number line or in one dimension. And what we're looking at with the absolute value of x equals 4 is we're some number 4 units away from the origin, which means I can either go 4 to the right of 0, or I could go 4 to the left of 0 and end up at negative 4. Both of these have the same magnitude or distance from the origin, from some number and 0. Hopefully that gives a little more spin on absolute value, because sometimes people will see absolute value and they'll think, oh, this is positive or negative 9. That's not true. So we're going to practice a little bit, and then we'll see how this actually comes about in 2 dimensions with x and y and some of our graphs, because later on when we talk about integrals, which is a word that you don't understand right now, this concept comes back when we're dealing with just positive areas. So how do we solve an absolute value problem? Well, we write it as 2 separate things. We take our 3x plus 1 is equal to 6, or our 3x plus 1 is equal to negative 6. We subtract 1, and then we divide by 3, so 5/3, or we subtract 1, and we divide by 3, and we're left with negative 7/3. The fancy way of saying this, the distance between some number and negative 1/3 is 6. So the number that I could be is either 5/3 or negative 7/3 that meet those conditions. So let's write our solution in a nice ordered way. Negative 7/3, comma 5/3, and we'll box that in. Simple algebra 1 type of problem. Now what happens when we have absolute value and then an algebraic expression? Well, we do the exact same thing. We're going to separate this into 2 separate cases. So we have our positive value, or we have x minus 4 is equal to, and I'm just going to put a negative sign in front and write 2x plus 3, which means that the negative goes to both of those terms in that expression. And now it's as simple as getting the x's on one side, getting the number on the other side. So x is equal to negative 7, or if I get the x's on one side and I get the numbers on the other side, I'm left with x is equal to 1/3. So in this case, my 2 solutions are negative 7 and 1/3. Inequalities present slightly a different case, because instead of looking for one exact solution, we're looking for all of the solutions that satisfy these conditions. And with inequalities, we want to always compare to 0. That's really what we want to look at. Just to save some room, the distance between some number and negative 5 is greater than or equal to 2. That's the question that we're answering. So if we follow the same logic, we have x plus 5 is greater than or equal to 2. Everything stays the same. Or we have x plus 5 and negative 2, and because we have inequality, we change the direction. So we have x plus subtract 5. Let's just jump right ahead. X is greater than or equal to negative 3, or x is less than or equal to negative 7. What does this look like on a number line? Just to give you a visual. Say we have our origin 0. We have 1, 2, 3. We have negative 3. And then we have 1, 2, 3, 4, 5, 6. Negative 4, negative 5, negative 6, negative 7. Both of these are filled in. And all of the values in the highlighted region give us a solution to this inequality. Now, as I said before, instead of just working with one dimension and one variable, what happens if we talk about functions? This might be new to you guys. So let's take a look at the absolute value of this quadratic. And if I expand it out, you'll see that we have x squared minus x. The same idea applies, but you have to be a little creative in your thinking here. So if we take a look at just our basic inside function, or x times x minus 1, we would have a parabola with x-intercepts at 0 and 1, and it opens up. We could find the vertex if we wanted to. It'd be at 1/2, and our parabola opens up that way. Well, as we said before, absolute value is a positive number generator. and the outputs are the y values. So what happens is that everything that's underneath the x-axis, or a negative y value, gets inverted. And so if we sketch this h of x, our other function, that is the absolute value of x squared minus x, we still have the same x-intercepts. But what's going to happen here, and let's just do this in a slightly different color, is as we approach our x-intercept, we hit it, and then we take everything that was negative once before, and it's now positive. And then it resumes being the original function. A very powerful little operation that we throw in here. And it comes back in chapter 5 near the second semester when we're talking about area, and we only want to look at positive area. So that's why we're showing it to you here. Last bit for this part 4 video is we're going to talk about circles. This might look familiar, especially if you remember your distance formula, or if you look at your Pythagorean theorem. We have our x minus a, in this case, squared, plus y minus b squared equals r squared. Everything is equidistant from the center a comma b, and with a radius of r. Now, if this was in class, I'd ask you guys to do this problem on your own, and then we would come back to it. So if you want, pause the video. If not, we're just going to move ahead. So this equation says, find the equation of a circle with center at negative 3, 4, and passes through the point 0, 7. We've got two pieces of information that we can start filling in. So we have x minus a negative 3, or x plus 3 squared, plus y minus 4 squared equals r squared. Now we're only missing one variable, so we need to utilize the second piece of information. And we know that the x value is 0, so we just plug that in. And then the y value is 7 squared equals r squared. So we're left with 9 plus 7 minus 4 is 3 squared is 9. It's equal to r squared. Therefore, r squared is equal to 18. Be careful, it's not asking you for what the radius is, although some questions might. It's just asking for the equation. So keep it at r squared. You don't need to write it as 3 root 2. It's not the point of saying what this question is. So then our final answer here is x plus 3 squared plus y minus 4 squared is equal to 18. We'll box that in. Simple, easy, straightforward. Question that's not so simple here is find the equation that passes through the origin with x-intercepts negative 3 and y-intercept 4. So I challenge you to draw a picture here. And if you're able to draw a picture here, it kind of illuminates what this problem is asking you. So our circle passes through the origin, has a y-intercept of 4 and an x-intercept of 3. So I'm going to do my best to draw this circle out and not make it too lopsided. But we're looking at a center of our circle somewhere here. If we know that we have two of these endpoints, these x-intercepts, and we know that they're equidistant apart, 1, 2, 3, 1, 2, 3, 4, what we can do is find the center by finding the midpoint between these two x-intercepts. So our center would be negative 3 halves, comma 2. And note, this is just using midpoint, because the midpoint has to be the center has to be in between those two x and y intercepts. So we can start writing the equation of our circle. X plus 3 halves squared plus y minus 2 squared is equal to r squared. Then we can solve for r just by plugging in one of the 2 points. In this case, I think it's easier to plug in the origin. So plug in 0, 0, and we will find our radius. So we have 3 halves squared, which is 9/4, plus 4 is equal to r squared. 4 is 16/4 plus 9/4 gives you 25/4 for r squared. So just to wrap this up, the solution, the equation of our circle, given this information, is x plus 3/2 squared plus y minus 2 squared equals 25/4. Last problem, before I let you go and have you guys work on some problems here, is given something that's in general form, come up with the equation of the circle, which goes back to the first video. I need you to remember some of these things. Is we need to be able to complete the square twice. So my advice to you guys, group the x terms together, then leave a little space, plus group the y terms together, then leave a little space, and then we move the 11 to the other side. We're going to do complete the square twice, so we take half of 8 and square it, which is 16. We take half of -4 and square it, which is 4. Whatever we do to one side, we do to the other, so we have to add 16, we have to add 4, which is 20 minus 11, so we're left with x plus 4 squared plus y minus 2 squared equals 9. And it says find the radius and the center, so we know that the center of this circle is at -4, 2, with a radius of 3. Once you get good with this, these problems are pretty straightforward. So we'll stop here, and then I'll see you guys in part 5.